Hello, hello. Good morning, everyone. We're waiting for everybody to get settled in. So let's go ahead and do that first. And put my chat up. There we go. There we go. Beautiful. All right. Well, thank you everyone for being here. Again, I appreciate your patience with me with last week. I do want to make sort of a first statement that I actually kind of based on what's happening with family, I have to actually go home to Chicago on Wednesday. You know, without giving you guys too much information, my mom's just kind of going through a lot of different surgeries right now, and my dad just needs some assistance and some help. She's okay, she's going to be fine, but she has to have retinal surgery done, and it's kind of a big undertaking. So I'm going to go home and kind of help see that through. So with that being said, we're going to move through 9 and most of 10 today, and then I'm going to pre-record 10 and 11 for you guys. So you won't have virtual meeting on, I'll make this as an announcement, but you'll have the pre-recorded lecture like I did for y'all this past time. Hopefully by the time I come back after this weekend, things will be a little bit more normalized and we can get back to kind of normal scheduling. But again, I greatly appreciate you guys being patient with me. This is just sort of, it's like when the floodgates open, sometimes it's just a lot, you know, it just kind of comes down without stopping. So I'm sure we're all aware of that in this weird, bizarre time of life. But with that being said, I am working to get through your project proposals before I leave, or at least on the plane, so I can give you guys that feedback so you're ready to go. And, you know, I put up the video of kind of how to move through the project proposal, which talks about how to look at peer review research and all of that stuff. But again, if you have any questions about that, please make sure you're contacting me. Additionally, you have a writing center that will help you put things together. They know how to find, you know, primary, secondary, tertiary resources for you all. The biggest thing that I want to really harp on is you are required 6 peer review research papers. It doesn't mean you have to read through all of them in their entirety. What it means is that you just have to have 6 of them ready to go for your annotated bib, so I can see that you're looking for these things. This is all just me trying to keep you guys on par with the material, because I know it's a big project to complete. So I'm kind of trying to break it up in smaller sections for you guys to digest and get those things in, so you're making and hitting those assignment deadlines without just saying, oh, here's one giant massive thing you've got to put together and make sure you've got it completely done without any feedback before you submit it. So just the overall of what I'm looking at, I mean, it was a very quick looking at what you guys had sent to me this past Friday, or this past weekend, I should say, with regard to your project proposals. They look pretty good. I don't, you know, for the first couple that I looked at, it didn't look like anything crazy in concern. But of course, I want to give you guys feedback. And more importantly, please go back and review that video. And I want to make sure I share that to y'all now. Sound perfect. You know, in the announcement section I made for you guys, right? I posted for you all a guide video for how to go through the project proposal, right? So if you go to Panopto recordings, granted, I made this last time that I taught the class, but it's got for you an urban space proposal guide video. And again, it's about 19 minutes long. It's a lot of me talking, but it's going to hit on everything that you will need to have in terms of how to move through this project proposal. And again, when you get to the secondary half of class and we start to move into Unseen City and you guys have to do it about your urban animal, this will be very similar in the way that we put this together, right? You'll have to put together a proposal outline. You'll have to do the annotated bib. So once you kind of have this understanding on the front project, you'll have a good understanding of what you're supposed to do for the backside of the paper that is for the second half of class. So again, if you've not had a chance to look through this, I promise you that a lot of your questions that you probably are having about how to put this together are answered in here, right? Again, I try to go through this step by step as streamlined as possible. I try to show you guys how to look for peer review resources. I try to tell you how to make life simplified when you're looking for things. in the context of trying to gather research. So please start here. If it's not answered here, then absolutely write me an email or let's set up some office hour time where you all come and talk to me and I can help guide you through that. I want to pause here. Any initial questions with regard to that? I know we just submitted our first thing, so we're still kind of waiting for that feedback, but is there any initial questions I can answer? And again, maybe you just need to take the time. Maybe you're like, oh, I didn't even really know that that video was there. Or maybe I missed that from Dr. Varga. Maybe you just need the time to go through it again. Please check it out. Like I said, I try to be very strategic with going through, putting the proposal together, making an outline, putting the annotated bib, how to research peer review, to what your final kind of overall submission should look like. And I think I even have a couple examples in there that kind of walk through sort of just the flow and the look of the paper. Any questions, come and see me, okay? Groovy. Okay, then without further ado, just to kind of show you all where we are and just kind of reiterate that. Right, today we are working on catching up to speed. We're going to do chapter 9. We should easily move through chapter 9 and chapter 10 for a good chunk of it. And then for Wednesday, I will post an announcement. You will have no live lecture. We will not meet. I'll be on an airplane flying back to Chicago, but I will finish up chapter 11 and we'll be caught back up to speed again for you all. So wherever we leave off today, I'll pick up and I'll finish chapter 11 as well. Additionally, most of you are doing a great job on the discussion board. Some of you guys are really getting deep down the rabbit hole on what you guys are researching, which I think is fantastic. Some of you guys have some great feedback and output. And just, I would say if you're getting any feedback from me on questions, or maybe you've missed a half point or a point, it was really me just looking for you to expand beyond just sort of that surface level, right? If you're just sort of saying, the environment could be impacted by humans. Well, of course, we know that, right? We know that that's going to be kind of a standard given. Go a little bit deeper. Talk to me about, again, some of the context of things that we've talked about in class already. Most importantly, whatever the discussion board is on is going to be over the chapter we've been discussing. So go back into that PowerPoint. You have the PowerPoints posted for you. Go back in there and look at some of those details and say, oh, this is probably a little bit more of that below the surface. And again, some of you are doing phenomenal. Some of you are going out and finding resources for me. Some of you are finding websites for me. Fantastic job. And some of you are telling me in your discussion boards you're really enjoying it. That's been really awesome. That's the feedback I really want to hear. Last but not least, and I don't want to take too much time away, but under the discussion boards, a couple things. The first and foremost being that you have your discussion boards that you're moving through. Please don't forget I've got the fun, cool things to share with class. I think some of you have used it, which has been awesome. I've given a little feedback inside of there. But if you guys have anything cool that you find in your backyard, or we talk about something and you're like, oh, wow, that's really crazy. I have that going on in my backyard. Share that here. I try to check it at least, once every other week to see. So if you got something cool, share it. I love to see new things that are going on. And then finally, the last thing I wanted to make sure, just to kind of to reiterate it, you guys are probably going to see all of these due dates that are kind of coming up here. Don't stress about those. It's not that each one of you is going to have to do this. It's that you're going to have to work collectively with your group and you will be given one of these presentations that you will have to do. So these are just posted because I'm waiting to fill in the gaps of who's going to be working with who. But for this is just when those presentations are going to be given. You will not be required to each present on each one of these chapters. That's far too overwhelming. So yeah, just hold tight on that. Hopefully that answers any additional questions y'all may have. Okay, well, without further ado, then let's go ahead and get into the information for today. And we are going to start with our urban flora. And again, I think these are kind of the fun chapters now that we're kind of getting it away from, not that urban hydrology and urban, biogeochemistry isn't very fascinating stuff. It's part of the ecological environment that we have to think about if we're just thinking about general nature, but applying that to urban ecology. But now we get to talk about like the plants and animals, right? So really, these are going to be two kind of pretty important chapters for you guys moving forward on your project proposals, right? Pulling out information from these two chapters as to why am I choosing this specific native species of plants, or why am I choosing this specific native species of animals? You know, come back to the details of this chapter and use that in those paragraphs of your project proposal to support why you're making those choices. And again, as you're looking at that peer review research, just the basic introduction of what you're looking at for your native species of plants and animals, they're going to give you a beautiful introduction as to why they're native to that area. They can handle the temperature, the climate, the amount of rainfall, or they evolved over time to be able to reside in a more southwestern desert arid type of environment. Use that stuff to your advantage. That's all a part of trying to convince me why your urban space is going to have a good impact in going and what you're designing to put into that, you know, particular area. Okay, so urban flora first and then our urban fauna. So plants first and then our animals in chapter 10. So the first thing I kind of want to ask you guys is, because I think it's always nice, this is something I like to do in class, you know, what plants can you think of in your backyard, or, you know, maybe in and around your complex of your apartment, or if you're staying with, you know, other family members or friends, or maybe you're even in the dorms on campus. What are some of the, you know, are there any particular plants that you can think of specifically that you're like, yep, that's a native plant to Texas, or, you know, based on kind of the arrangement and the climate of Texas, I think, yeah, this would be something that would only be found in this particular area. Are there any of them you can think of?
Like around the spring, I see like a lot of tulips around the Addison area.
Yep, tulips
During
are really,
spring.
yep, tulips are really great. What is another flower that obviously we see all the time? Usually late spring, early summer.
Bluebonnets.
Bluebonnets, right? Our bluebonnets, our native species to our, you know, the state fair or the state flower of Texas, right? This is so absolutely native, right? We've named it the state flower itself because it is native here. Are there any plants you can think of that may be a nuisance in and around your area? And maybe just beyond just like generalized weeds, right? We know that weeds are definitely invasive and not awesome, but are there any plants that by default maybe are actually a nuisance?
Would Bermuda grass count as that category?
Sure, and maybe you could tell us about why that would be a nuisance potentially.
Well, I know it's partly because it's not a native plant, and it's a grass that is pretty much just implemented everywhere in lawns and stuff, and it unfortunately chokes out any other native plants that are in the area.
Yeah, and what are some of the characteristics of it that let you know that it's not the same as the other grass? Like, what are some identifying things that you can look at and say, like, oh, yep, that's it?
It requires a lot more water, I know, and just general maintenance to enable to increase its survivability in compared with other grasses.
Sure, it's usually got like a nice thick blade to it, better surface area, larger surface area, better ability to capture photosynthesis. I can choke out other things below me because of the shade. Because I do that, they decrease, so their water goes to me now, their nutrients come to me, right? It can very quickly proliferate. It can grow very, very rapidly. Great example. Are there any other things that we can think of in terms of nuisance in plants? One that is often seen in the wintertime, it'll become much more prevalent, that when you walk around trees and you see it, all the trees, if they are a deciduous tree, meaning they lose their leaves in the springtime or wintertime to grow back in the spring, you'll in fact see in the middle, there'll be kind of this ball-like structure that's still green. And there's a dead giveaway on those that let you know what it is in particular. Little red balls that grow on these kind of green masses in the middle of these trees. Does anybody know what that is? I'll give you a hint. Some people have a tradition of kissing underneath it at Christmas time.
The mistletoe.
Yeah, mistletoe is a very invasive species here. It chokes out, it can actually choke out the plant itself, and destroy the nutrients and things like that. That was something I had no clue about when I moved here, but I remember seeing these sort of very bright, vivid green balls in the middle of trees sometimes, or shrubs and bushes that had lost their leaves during winter. And I was like, what is that? And somebody that was a native Texan was like, oh, that's mistletoe. It's a very invasive species. Never even knew that. Last but not least, is there a tree that you can think of that wreaks absolute havoc if you have allergies down here?
Cottonwood trees.
Okay, is there a particular type of tree, specific species? The cedars, there are cedar trees that release massive amounts of pollen. And they're a unique species that's not the cedar that we think of in terms of the hardwood, so to speak, that we want to make tables and chairs from, but they're really, really nasty and they're very prevalent. Most states do not want you cutting down trees, right? You want to keep your trees because they add not only shade and reduce heat, but they have a beauty to them. The cedar tree in the state of Texas, I think, especially in South Dallas, where Southern Dallas, where we are, you can take out as many of those as you want. In fact, it's encouraged to take down cedar trees because they proliferate and they cause such a nuisance, mainly with allergies, but they choke out other tree species very fast. So again, these things are all considerations we need to take into our mindset when we are, planning and creating and developing. And again, cottonwood trees, yes, cottonwood trees are a huge one, right? They can, when they release all that cottonwood to the air, and I'm sorry, maybe I didn't hear that. Maybe that's what Mr. Rodriguez, maybe that's what you were saying, and I just caught the wood aspect of the tree. Sorry about that. I didn't realize you were maybe saying cottonwood. But they're a pain in the butt. Long story short, they're a really, really big problem. And again, you guys know that the things in our urban environment are an issue, because I challenge you, go out and look at your car, beginning and end of spring, beginning, end of summer, right? You've just got that film of just constant pollen on everything down here, right? So again, wreaks havoc on I've just really realized in the past week and a half, my allergies are through the roof again. I mean, I want to like cat claw my eyes out every day because it just feels like it's just itchy, 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 itchy. So I know that there must be something in the area that's causing this to be a really big concern again. So you can work locally, right? A lot of us who maybe are homeowners, or those of us that, maybe want to have a balcony of some plants like I do in my apartment complex, you want to ensure that you're trying to cut down on watering costs, energy, things like that. So when you go to the store, you want to work with, hey, what are my native plants and what are my native species of things that I'm working with? You can also go to a place like the Audubon Society and you can type in all of the information like I've got here for you guys, right? And you can completely search exactly what type of plants would serve best, right? So you can look in here, you can type in your little zip code, right? So I'm going to hit search here, see if it works and brings it up, right? And now it's going to tell me it's got 86 different results that are best. And now I can kind of funnel it down. Hey, I'm looking to plant trees versus shrubs versus succulents. I'm going to say, like, what are the things that could be available to coming, right? What do I want to attract? Are there specific types of birds I want to attract, right? Because that's really the fundamental nature of what the Audubon Society is. So really, you can plant a beautiful backyard in your own backyard based on exactly where you're located. These are all the things that it's telling me would be really advantageous for me to plant based on my zip code. And here are the different things that I can attract, right? Here are the different types of birds I can attract. It'll tell me more about you know, what are the things it can, okay, so in this one, the American sycamore, I can plant, it's gonna, you know, help other trees to grow. It's gonna be a fruit bearing plant. It's gonna bring butterflies and caterpillars. It also produces nuts. This is really wonderful that this exists because it takes a lot of the guesswork out. I find every year that I go and try and, you know, pick my pretty flowers for my balcony, and I love doing that. I love my little dirt therapy that I have. I always notoriously end up picking something that doesn't do well on my deck. Is it because, oh, unfortunately, it probably should have been one that went in the ground versus a bucket or versus a pot, you know, versus, even though it says full sun, is my sun too much sun? You know, every year it's this kind of push and pull to figure out what works best versus what doesn't. But if I was ever to purchase a home down here, right within this area, absolutely, I'd come here. I love birds personally. I think, you know, when I become an old lady, which I'm well on my way to, I will definitely probably get my little binoculars and do my little bird watching. I think birds are super cool. The songs that they make are super beautiful and lovely. And the cool thing is we have a ton of beautiful songbirds down here. If you're unaware of that, I mean, we have just some beautiful, amazing songbirds that come to Texas as part of either their stopover or just are native to here, which are fantastic. So again, our diversity within our urban environmental conditions is really important. Where are we putting things down? How are we creating that biodiversity? Do we want it to be more natural in terms of having grass and green space, or do we want it to be more natural as in we're not at all? We're just going to sort of let the wild wilderness come back in and do its job. So your Chapter 8 discussion board sort of touches on this. It talks about, you know, if you're planning in an urban environment and you're thinking about a space, would it be more beneficial for allowing that to go back as natural as possible? Well, theoretically, both of these have aspects of nature into them. It's just what aspect are you trying to create? Are you trying to restore an area, right? Or are you trying to create an area? And again, these are things to talk through in that discussion board. Well, it depends on the circumstances. If I'm trying to create something that's a renewal or a regenerative process, I may simply just want to go hands off and say, let it just spontaneously do what it's going to do. Let the weeds come in, let that attract the grasses, let that attract the bugs, because I want to restore it back to as natural as possible. But maybe you want to create a green space inside of an urban environment, right? And you have to designate that as being uniquely different than the rural countryside. Then there's going to be some management to it, right? Versus the natural environment is just going to be something that you're going to let it do all on its own. So again, in terms of thinking of this, we also have to consider what are the natural resources of the area. The soil quality that you have in your backyard that you guys tested and worked through is uniquely different across each of the students of this class, right? Each of you, some of you are coming up acidic, some of you are coming up basic, some of you are like, it's actually pretty neutral because nothing really happened to it. Versus how that's different than the Midwest in terms of its dirt and soil content. We absolutely need to look at what is the makeup, and more importantly, what are some of the natural resources that we can obtain from there. Northern Mexico, super rich minerals like silver, copper, lead, iron, oil, right? So again, these are all things that do we want to mine for those resources? Is it conducive to plant because of these things that are currently in the ground? How will things grow and respond to that? Or what is growing in that natural environment as of right now? So again, local geographical or geological and geomorphological conditions, again, high plant diversity and natural minerals are all not only going to draw in potentially plants and nature to an area, people are going to move there too. And now it becomes that competition. How do we keep that balance? Because we're coming to this area for these minerals and these resources. But if we go in and just plow through, you know, we degrade them all, and then what? We have nothing left to kind of turn back to. So we have to restore and maintain that balance. Again, also being a port or a way to communicate effectively. If I know that there's a lot of good things going on, if I know I've got gold, silver, or I've got copper, or I've got these particular minerals that are really good. This could be a way to actually advocate for protection mechanisms, right? To say, we don't want just anybody to run through and, diminish the quality of this particular area. We need to have this type of preservation in place. It shouldn't be a free for all, right? And so actually, we're maybe seen as, well, you're drawing attention to it. It also is a great way to actually put a stopgap measure in and allow for protection to be in place as well. So how do plants perform in the urban environment, and how do they spread, decline, and survive? Again, these are all things that we need to think about. And more importantly, what is the general makeup of the conditions of the environment that they're going into? So what are the ranges of urban vegetation that we have to consider then? Overall, there are, definitely different forms. We have to consider those things that are considered cyanobacteria. We talked a little bit about pond scum and atrophication and eutrophication. We talked about we haven't talked about, but we want to think about things that are low level kind of ground creepers that sort of set the stage in holding down soil. And those are our non-vascular plants. These are very small, inconspicuous, right? These are the things that sort of are primary movers that come into an area. And once they've established and taken root to start to do synthesis, allow for those minerals, allow for the cycling of matter and material to kind of go through, and we're building healthy soil. Now we can move in and have vascularization. We can have trees that grow up big and tall, and bushes and flowering plants. So again, there's kind of this flow in terms of ecological niches that we have to create to allow for bigger trees and shrubs and plants, things that grow up and out of the ground. We have to start with something that is going to allow for this transition to take place. Something that can be a producer, start to stabilize, start to bring energy and minerals and nutrients better cycling through the soil, right? This enhances even further. And then we move on to, again, our vascularized or our big growing trees and flowers. So again, our cyanobacteria, this is kind of that sludgy stuff that, again, just as this picture shows, right? We've probably seen it growing like pond scum on the top of the water. It can be found pretty much everywhere, right? And again, it's exactly that. It creates a version blue-green in terms of its color that it bounces back to our eyes, but it does photosynthetic properties, right? It is autotroph. It can produce and consume its own energy. That sort of lays down the foundation. And realistically, this pond muck that we see, this is really the foundation of how all life on Earth began. It was really these first little cyanobacteria that sort of allowed for Earth to transition out of the water and come onto land. So with that, dampness is very important for these. And as we've mentioned in the last chapter, fertilizers can completely offset this balance, meaning if we add in a bunch of fertilizer, these things are going to be like, heck yeah, I won the lottery. I've got all this nutrients coming to me, and they can form these massive, thick, top layers over not only just ponds and waterways, but out in the ocean. They can cause these algal blooms that can choke out plants and organisms underneath the water itself. And again, this is what we've talked about. And again, this can happen not only just in the ocean, it can happen in a lot of different places. So again, this is something we have to constantly account for in any open body of water that we have, especially if it's an open body of water that we know there's other life in that we want to be able to enjoy, right, and live and thrive. There's also this aspect known as lichens, and lichens are a variation that is greater in towns than between them. So again, lichens are really important. If anybody's ever taken Bio 1 or Bio 2, I should say, with me, lichens are things that are composed of two things, typically a cyanobacteria or an algae, and combination with a fungus. If you do not have either of those, you do not have what is called a lichen. The lichen is, you've seen this. This is something that grows on the sides of trees. It looks very, this one's very beautiful. This is kind of a unique arrangement of several species, but it typically has kind of these frosted flake look appearances. And again, incredibly important symbiotic relationship. We have the thing that can create and sustain its own life by producing its own energy and consuming its own energy. And then you have this beautiful merriment with something that is a perfect decomposer that can break down and reuse those nutrients to create more lichens, right? And now if you're a tree and you have this symbiotic relationship on you, right, it enhances your growth. So these things are all building on each other to create that naturally occurring ecological niche out in nature. But these are things that you want to allow to happen inside of your urban space as well, because it helps to maintain that balance. Again, lichens, we always see these. We can see these all the time, especially after big, heavy growth or big, heavy rainfalls, right? Wind, they can disassociate and travel to other neighboring trees and start to grow, right? These are all things that we can find within our urban environment. Additionally, and building on kind of the secondary aspect, which was our non-vascularized, our low inconspicuous mosses, liverworts, and hornworts, these things are growing everywhere. And again, it's kind of got that beautiful soft carpet feel to it, right? Typically, we can see it kind of growing between stones and cracks. Again, stabilization, low growth, it's picking up the soil that's in between the cracks here of these pavers. But out in nature, in terms of stabilizing an environment, these are fantastic because they lay down sort of the bed hold of the soil. The soil doesn't blow away then. And now bigger things can move in and start to grow up and out of that because these bryophytes and ferns have stabilized. Also incredibly important for an urban environment. We need to ensure that we are maintaining what we're putting in as green space. And so we want to make sure we've got a healthy dose of our bryophytes and ferns so that we can stabilize our soil for our trees and other things to grow. Finally, that leads into the biggest, which is our vascularized plants, right? You have a vascular system, blood that moves blood through your body to feed you, right? What do plants have? What do they have in their body considered to be vascularization? They don't have blood, of course, but what are the two main parts about the tree that we would consider a part of their vascular system? This kind of goes back all the way to basically grade school introduction of how trees move water and food throughout them. What are the two fun terms that we can think of? Yes, we have roots. Yes, we have leaves, but I'm going a little bit more specific. What are the two main things inside of plants? And not xylem and
Phylum.
yeah, phloem and chloroplasts are important. So xylem and phloem help move water and nutrients. They're kind of like your blood vessels. The chloroplasts are really important because they are the places where photosynthesis takes place. So they are the place where they are producing and creating that food that then will be moved through the xylem and phloem, right? So when we say that plants are vascularized, we mean we have these elements inside of them that allows them to grow big and tall because they can transport now between the xylem and phloem and move it throughout the system. This is why trees can grow hundreds, if not thousands, if not hundreds of thousands of years old, right? Because they can continue to kind of keep growing. So gymnosperms. Again, gymnosperms are things that are going to be pine producing. And again, they typically are pines or evergreens, things like that. They are really fantastic at, surviving in a lot of different environments. The best of them is our ginkgo biloba. So again, they have these sort of fan-like structures to them. It's very easy to identify this species of tree. And we only put males inside of urban environments because, again, the females produce these sort of large, fleshy fruits. And when they fall to the ground and start to decompose, they smell terrible, really, really awful. So we only tend to put male gymnosperms of the ginkgo biloba inside of downtown areas because that beautiful fan shape makes nice surface area and it filters the air. It does a really good job. It tolerates high levels of pollution. It can tolerate high levels of pollution in the soil, but it's really good as an air filter for us as well. So this is a good one that we tend to go after when we urban plan. Finally, of that group is our angiosperms, our flowering plants. And again, this is the globally dominant plant form that we think of. And it's definitely, globally dominant because if I have a flower, if I'm able to produce a flower, I'm able to attract things that can move me to other places, right? I can now actually create lots of genetic diversity of myself because I can rely on a little bumblebee or any little animal that's going to pick up some of the pollen from one plant and carry it to a whole different version, right? Still within the same species, but it's kind of like humans engaging and finding a mate, right? That's not of the same family, and you're creating more genetic diversity. That's a good thing. Same thing with the flowering plants. They want to enhance that so that they're always genetically prepared to survive anything that may come their way. Now, the problem with these is because they are the major dominant form, everybody wants to have some, we want to look at these beautiful bright things. Not only are bugs attracted to them, we're visually attracted to them. We're odoriferously attracted to them. We like the smell of them, the way that they feel, the way they look. Heck, we give them to each other as gifts, right? But the problem is that they can cause really big issues in terms of infrastructure because they can root up cement in other areas, which can cause damage to buildings or water systems or et cetera. Right, and I'm sure we've seen some version of this. No time present that I have in terms of Texas. There's a lot of infrastructure issues with, again, what we talked about, the sand kind of constantly shifting, right? That's also a challenge that the trees, the angiosperms, are going to have to deal with as well. So what are then some of the origins of our urban vegetation? Again, native species are still found, but many plants actually originated from other areas. How are they getting here then? Where are they coming from? I'm thinking of palm trees in particular. Palm trees do not belong in Dallas, Texas. Palm trees don't belong in Texas, right? Palm trees are meant to be near coastal lines where they are getting constant access to ocean breeze. They're able to bend and move based on, winds and hurricanes and things like that. They aren't supposed to be here, but they can tolerate living here, right? Believe it or not, even up in Chicago, in my hometown, there were people that were very, very selfish, not just one particular group of people, but people who happen to have the money, that have in-ground pools, and they want it to feel tropical. They'll go buy palm trees and plant them into pots for just the season, which is terribly cruel to me and unbelievably selfish. But right, that palm tree is absolutely not meant to survive at -30 degrees for months on end. So it doesn't, right? But down here, it's still enough crossover. There's still enough of the overlap in that Venn diagram of temperature and climate that in fact they can survive and thrive here. Same thing with bamboo, right? Bamboo is not native here at all, but it's something that can easily tolerate the temperature here, and it grows and proliferates very well. So where and how are they coming back? Some people bring them here, but if we think through kind of the development of the United States, the settling of the United States, we created railroads, and then we created harbors with boats and shipping and freight. And then of course, all these other things that we can think about that are moving. And trust me, even though we know that the plant doesn't think, so to speak, it's clearly evolved these mechanisms by which it is reliant upon things to move it around. And believe it or not, we're part of that now, right? We just think we're separate from like the birds and the bees. No, we're absolutely a part of that in moving things around right now. And a lot of urban tree species, I bet if we did a deep dive into the research, would probably showcase that they're actually evolving so closely now with humans that they absolutely rely on our mechanisms of, again, garbage trucks and golf courses and human feet moving things around on the bottom of their shoes. It's really fascinating. That's why the urban environment itself is almost its own ecosystem, by which some things that are evolving inside of here are not found anywhere else but inside of an urban space. So today, more of the urban flora is a mixture higher than the native plants originally. We humans like pretty things to look at. We humans bring things with us. Unfortunately, in most urban environments, you're probably going to find more of an outside influence versus the native dwelling species as possible. And again, the biggest one, the Europeans. As they came over, they brought plants that they were, deeply attracted to. We'll see that with animals as well. We'll see that in Unseen City when we get to that as well. So today, horticulture stock influence species availability in two different ways. The actual species that have been planted, and again, the contamination of horticultural stock by non-native plants. We sort of just beat that one into the ground. So European species, these tend to be more successful in colonizing people-made habitats than species from other countries. Again, why? Why would that be the case? Well, because these species are better equipped than Native American species to exploit the conditions. These species that were brought over by European colonizers have been inside of every urban environment as it's grown and grown and grown. If we look back all the way to the end of the 1700s, beginning of the 1800s, when we really started to colonize America, every time we developed a new city or town, we brought those particular plants with us. So of course, they're going to be really well adapted to living alongside of us versus things that are natural. And in fact, they outcompete the native, and again, not Native American is in terms the indigenous people, native as in to America versus native to Europe. Yet very few European and Eurasian species are found in Japan. This is kind of just a very interesting thing. So during World War II and the isolation of Japan from the rest of the world, right? Kind of UN stuff. A lot of people weren't allowed to go to Japan, and vice versa. They weren't allowed to come really to any, of European or Western type civilizations because, again, of political isolation. So because of that, Japan has sort of remained this sort of completely native place with only things that are found in Japan. Purely, I think that's a beautiful thing, right? Because now you have this sort of isolation of this niche, this ecosystem that you can't find anywhere else on Earth. Additionally, what are we seeing more than ever now? I want to eat organic. I want to eat healthy. I want to know where my food is coming from. Fantastic, right? That's a great thing. I think that's going to be the biggest change for humanity as we go forward. We need to know what we're putting into our bodies, because what are we seeing? Higher incidence rates of cancers and illnesses, and people are living a lot longer now. So we have to make sure that we're able to support our body and our mechanisms for survival as long as possible. So again, biggest cultural flux of people since World War II now are literally digging up their own backyards to plant and grow food for their own homes. This is sort of the biggest cultural shift we're seeing now more than ever since World War II, when people were genuinely starving and they needed to grow food, right? They were down on their luck because all of the men were off to war, and women sort of took up the reins and really had to provide for their family. How did they do that? Well, they started to grow their own food mainly. So now there is a whole new wave of urban flora and new plant species in cities. Again, corn needs to typically be grown out in the outskirts of town, typically in the Midwest. Now you can go to people who will get 5 by 5 foot grow boxes and they'll grow a whole little pallet of corn, right? Or a whole little pallet of soybeans or things like that. So now we're seeing this influx of things that were once very rural now coming into urban environments. So I think I have this. This is just kind of fun. We came over on the Mayflower to a timeline of North American native species that were invasive, that were not conducive to here, or meaning they weren't from here, they were brought here. All of these, it's kind of fun to look through here. Fennel, English ivy. What's another one that was really interesting to me? Periwinkle, gold rush rats. There was one for bullfrogs. Right? Somebody has done wild boars. I think boar is, you know, and javelinas is like the most notoriously thing that we think of when we think of Texas. We're like, oh yeah, it's these wild boar, not native to here at all. Actually, they were brought here. So I thought this was really fascinating. Look through it. It's kind of an eye opener in terms of things that we think, oh, that's American. That actually was brought here, very interestingly. So check that out if you have a few minutes. And again, our dynamic changes in urban vegetation change the overall richness and diversity. Urban plant communities are characterized by species that are adapted to disturbances. So as we take down an area, develop it, or maybe it was developed and now we take it down and let it go back to natural landscape. Most of these things, again, are going to be characterized by things that we're able to adapt very quickly to that. 90% of plants found in US cities are of the 50 most frequent vascular non-native plants, meaning it goes back to our European settlers. It could be explained by that it was very deliberate and unintended introduction of these things into cities by early settlers. They didn't realize it, but it happened. And then they also have specific biological attributes of these, resulting in obviously millennia of evolution with us and rudal species that were native, that have allowed them to get the one leg up and continue to thrive and survive. So what do we call a disturbance then? This is a discrete event in time that disrupts the landscape such that the resources are altered, the substrate availability of other aspects of the biophysical environment are now different. Maybe I was a moss that was able to grow on the side of a building. That building is no longer, it's taken down, right? And now there's a disturbance for me as that moss within that area. How do I continue to thrive and survive? Can I attach myself to something else? Was there specific nutrients, maybe from the cement that I was pulling, or what was the building material? These are all things we have to look at in terms of the flora and the change of that due to a disturbance. So again, natural discrete events that can happen in terms of disturbances, hurricanes, fires, tornadoes, anything, right? Those things are all naturally occurring, but now they're typically replaced by things that are unnatural in the urban environment, right? Arson, vandalism, industrial waste, things that shouldn't be there naturally, but again, will also cause that disturbance, so to speak. Most human disturbances can take place within 80 meters of the edge of a habitat patch. This degradation of the fringe is called the sociological edge effect, meaning people don't walk far to drop off waste in their environment. We can unfortunately see that if we drive down certain types of areas in the city, right? People will just dump things on the side of the road. That causes a disturbance within an area, even within that small little patch, right? So if there's not disturbances, then how do we then allow for things to move in and start to colonize? So the ability of non-native and native plants to survive these disturbances as plant seeds of colonized seeds are going to really rely on their dispersal. How far, how wide can I get? Additionally, how am I being dispersed, and do I need that resource? Natural ways of dispersal water, wind, pollinators, things of that nature, are now being replaced with vehicles, planting of seeds, picking them up with your feet, right? We just said that we have a unique ecological role now in causing the evolution of species that are only being involved with urban environments. So these guys were from Berlin. They demonstrated that they put out these giant nets. They're called seed traps. So it's literally that. It's just a very fine meshing that's kind of compartmentalized at the top. They stick them out in this field and they just sort of let them do their thing. They put them out there for a certain amount of time. Then they come back, they collect the seeds and they analyze that. So seed traps in Berlin demonstrated that traffic was blowing non-native seeds, things that were not native to the area, into peri-urban areas or things that were in the fringe of becoming urban, more than native seeds were coming into the city. So what does that say? That says that evolutionarily, these non-native seeds are getting the one leg up. They know, hey, go towards urbanization. That allows us to survive and thrive. And so the final aspect of this in terms of ecology, right? If we can survive a disturbance, if we can colonize, and then most importantly, can we have succession? Do we have offspring that now can survive and thrive in this area? This is the fundamental aspect of ecology, right? This is the crux of it all. Can I move into an area? Can I use the resources of that area? And now can I survive, thrive, and produce offspring? The orderly change in vegetation at the site that is predictable and directional towards the climax or endpoint, meaning can we create offspring? So Frederick Edward Clements, right here, this lovely dapper young man here in his little outfit, is known to be called the father of ecology as we understand it today. And he listed 5 major causes. Something happened to the environment which allowed for this thing to move in. Again, movement into an area. Establishing, how am I interacting with my environment? How am I interacting with other living things, my biotic factors? And then how am I modifying this to be able to survive, thrive, and reproduce? So primary succession, as we've already mentioned, right? Bare rocks, open area are disturbance. We have our non-vascularized plants that move in first, take hold, make sure that we're building up, stabilizing the soil. Then we have very inconspicuous and very small grasses and plants that come down. And now we transition into the secondary succession where our big boys, right, our angiosperms and our gymnosperms can move in because now we have a stabilized environment, a stabilized ecosystem that can allow for these guys to thrive and survive. We can't come in until this primary succession takes place. It's very uniquely different in environments like urban spaces because, again, things like sites clearing from construction may remove existing vegetation, which again is a disturbance. That disturbance now opens up new competition, new things can move in, and then it becomes an arms race. Who can win? Who can outcompete? Who can survive and thrive? So pioneer plants will do the same thing in the video, except their substrates are rocks, bricks, demolition heaps, and industrial waste. I have in here, I'm not going to go through that because we're running out of time and I want to get into chapter 10 for you all. But YouTube video here, it talks about primary and secondary succession on volcanic islands, right? Places like Hawaii that are super nutrient rich. There's vast, lush, you know, not urbanization, diversity on those islands. Because again, that volcanic rock that, you know, when the volcano spits that up and out or is coming as it's building underwater and, you know, spewing the lava out that settles and now creates these islands, they are just chocked full all of the nutrients that came from the core of the earth, right? That liquid hot magma that's the core of the earth has got all those beautiful elements and matter and metals and things like that that are really important to allow for all the life on our planet to occur. So dynamic changes, differential species performance, plant traits, their morphology, physiological, phenological properties all help to define their competitive abilities. This assumes that the combination of the plant's functional traits are related to the function of itself within the community, right? Form and function. Not only as we're designing buildings and landscapes, form and function in natural habitats, we're either trying to collectively create and landscape and manage, or allow for unmanagement and just allowing the wild to take over again. So what are some of the traits we need to make sure that we're looking for? Can we colonize places that maybe aren't super awesome for plants? Are there specific plants that can move into waste areas and vacant lots? Absolutely, we see it happening all the time. We have to make sure that they're able to receive lots of sunlight and they can handle hot, hot heat. If I'm a little plant growing up through the crack of asphalt, I've got to make sure that all the heat that's coming off that asphalt doesn't burn me out as well, right? And on it goes. And so we can look at this through what's called this space or stress disturbance space model. Again, what is the rise of increasing competition versus the disturbance rate versus the stress? We can kind of put all these things together in a mathematical equation and we can determine these things. Competitors thrive in low stress and are able to expand and exhibit rapid growth. Those that are stress tolerators can in high intensity stress, low disturbance, right? These are all just explaining how different species, they can be a competitor, they can be a stress tolerator, they can be a radial species, how they all are going to kind of play together based on, again, this triangular model that Grimes put together, this model that we have figured out for urban spaces. The last bit of this chapter talks again about things like our pests and pest management, because again, pests are going to be looking for not only food and support and shelter and water and all these things from us. If we put these into an urban space, theoretically, they could attract pests, right? We can attract bugs and beetles and things like that that want to bore into bushes and trees and shrubs and things like that. Those are still nuances for us. So how do we kind of overcome that? How do we deal with that? So again, before pest or disease, we kind of have high level diversity. After pest or disease, right, we're going to see a reduction because we're going to take down loss of some species due to either pests or disease. And then again, when we see the bounce back of this, this is where evolution is really going to shake out, because who was able to survive and thrive and live on? And again, more importantly, how did they react to that particular pest or disease should it come back again? This is all that push and pull of ecology. It's all things we have to think about in terms of our urban space as well. For our urban space, it's a lot of nasty things that we don't really like to think about. Spiders and ants and roaches and, you know, all sorts of fun things, flies. But we are the mechanism of that ecosystem for them. So we have to make sure, what is that balance we're striking? And is there anything that we're seeing is tipping the scales in the favor of cockroaches, right? So again, these are things we have to kind of think through. All right, let me see what this video is in comparison. I'm going to skip over this, but this is a nice job of talking about how the Audubon Society will go through and actually manage invasive species in areas that are green that they're trying to restore back. There was a big restoration project that happened in Keast Park lately, this past couple of years, that they were trying to restore Keast back to, you know, one area of the park that had a murder take place in there back in the 50s, I think it was, late 50s, early 60s. They closed that entire part of the park. They just let it go wild. Now they're going in, and that's not what this particular video is. I'm just using this as an additional example. Now they're trying to go back in and have, you know, the removal of those invasive species to let the native ones sort of thrive and come back and restore that area of the park. That is what this is talking about. It's specifically related to restoration up in and around the Great Lakes. So again, if you want to check it out, information here may be really helpful when you're putting together your project. So what is the future? The future then really relies on how we're able to think through these things. So again, I have a little video in here, but there's a lot of people who are working on urban green space revitalization. They're working very heavily on trying to integrate nature into building designs, right? And using native species as much as possible. Most importantly, what would be probably the biggest thing we're hoping to think about when we're putting these plants into urban areas? What would be the number one biggest advantage we would want these plants to do for us? Shade, absolutely. What else? What else do we greatly?
Maybe like air quality.
Absolutely, right? We absolutely want to put in the best filtration systems we possibly can get into our urban space. There's a lot of pollution, a lot of emissions, a lot of really nasty things that we breathe in on a regular day-to-day basis. Might as well use something to our advantage to work with us. So that is the end of chapter 9. Again, we're going to quickly just sort of start chapter 10. I'll probably get in, 10 minutes of this, and then I'll finish chapter 10 and we'll begin chapter 11 as a Panopto pre-recorded lecture for you all for this week to review. And I'll, again, make sure that I put that in this announcement. Okay, so this is kind of the fun one, right? Plants are awesome. Plants are fantastic. We know that we need to rely on them for diversity, but right, we always kind of like to see something in action, something moving, and that is animals within an urban environment, right? Insects, bugs, even though we're kind of creeped out and grossed out by them, they're fascinating, right? Because we can see them and we kind of want to understand what are they doing in our space. So urban fauna is exactly that. It's looking at that particular stuff. So just as we started with plants, what are some of your favorite urban animals that you can think of that you see or you always kind of stop and watch? Or is there any one or, one particular animal that you're kind of fascinated by that may be in your backyard, in and around?
Deer.
Deer, raccoons, turtles, okay.
Ducks.
Armadillos, crazy little creatures, absolutely. Chickens?
Vultures and hawks.
Absolutely, vultures and hawks for sure. Squirrels. And again, these are things that you maybe kind of like to watch. I think possums are hysterical because when they play dead, I think it's just so funny the way that they do that. If you've never seen a possum play dead, it's hilarious. They really do, and it totally works. When I used to have my dog before he passed away last year, the old environment that the old apartment that I used to live in, there would be possums that would run up and down the little gangway for the garbage. And my dog, as most dogs do, the prey drive sticks, kind of peeks in and they want to run after it. And it would be so funny to watch them just and fall over. And truly, my dog would be like, I have no idea what just happened. I want to chase the thing, right? That's what prey drive is. I want to chase you. Chasing you is what makes me want to eat you. When you just fall over dead, I'm not really interested in that anymore, right? It's kind of like little kids when they want you to chase them around and around and around. So absolutely. What are some of the least favorite urban animals you can think of? What are some things that you're like, no, not a fan?
Bugs.
Snakes, bugs,
Spiders.
spiders,
Oh, ants.
ants. Okay, you're a bit grossed out by ants. Roaches. Ugh, roaches by far and away. Every time I scream like a small girl when I see a cockroach because I don't like the way they move too fast. It's too fast.
Me too.
Oof. And I know that they're more afraid of me than I am of them. And roaches are actually incredibly clean. They don't like humans as much as we don't like them. That they are notorious cleaners. When they're not around us, if they come into contact with us or something, they'll clean themselves. They don't like it at all. So it's kind of ironic. We think they're such dirty little things, but they're actually very clean of their own accord. Not saying that they don't carry bacteria and are nasty, but they themselves are like, oof, I don't want to be around you either. But I think of all the things, they're my least favorite for sure.
Bees can be.
The flying cockroaches. I'm sorry, what did you say?
Oh, bees could be part of it. I don't really like them. there is a set of I don't know what type of bees it is, but it kind of started making a house in front of like the door of my apartment, and apparently it's those type of bees that if it stings you, you can be paralyzed.
Can you
And
take a picture of it and put it in the discussion board of cool things?
oh yeah, I'll try
I
to
mean,
do that.
safely,
safely.
safely. Don't, of
Yes.
course, don't try and aggravate anybody and.
Mhm.
get them
But we
to-
called the maintenance to like help us out because
Good.
it can
Good.
help do anything. So yeah.
Yeah, and I mean, I'm pretty sure we're all fundamentally aware of the difference between, bees and wasps and hornets. The really soft, fluffy the little guys that you see, the bees, you can let them walk all over you. You can let them come near you. Obviously, if you're allergic to them, don't do that at all. But for the most part, bees are completely harmless because why? What do we know about bees in terms of them stinging you?
They die if they sting. It's a last resort for them.
It's a very much a last resort. When they sting you, their stinger actually dislodges the whole back end of their abdomen. So basically they self-destruct. It's like they're pulling out everything. It's a suicide mission for them. They don't want to sting you, right? Hornets and wasps, they have a retractable stinger. So they can sting you many, many times, right? So absolutely wonderful. I'm glad you know that now. There's no reason to be afraid of bees. The more calm and collected you are around them, you can let them walk all over you. They do not care about you at all. Again, if you're allergic to them, don't ever take the risk. I don't want anybody to go into anaphylactic shock. But the ones that mimic bees or are, that kind of have that unique point that comes down and then that secondary abdomen that look mean, those things, don't mess with them. They absolutely can sting you multiple times over and over and over again. But the fluffy little honeybees, they don't want anything to do with you. So I'm glad that we learned something new. That makes my heart happy. Okay, so if we then think about our urban animals, they have done a wonderful job, fantastic job of cohabitating with us. And in fact, there are now certain, especially we'll see this in Unseen City, there are certain species underneath the larger genus of something that now only are evolved inside of urban environments. Pizza Rat, yep, everybody remembers Pizza Rat from a couple of years ago. He was a meme and I thought that was really funny. I also love our little mouse here, Moose muscaris. I mean, is that not the most adorable name for a mouse? Get out of here, it's just so dang cute. Obviously nobody likes them in their space. I don't want a rat or a mouse in my environment, even though I love the little Moose muscaris. Because again, the idea is we think that they carry bacteria, they carry viruses, they carry nasty things that we don't want on them, right? They can carry fleas and ticks of their own, which then could be a vector for us for nasty diseases. Absolutely. I don't want you going in and trying to pet your local neighborhood rat. That's not what I'm endorsing by any stretch, but it's really fascinating to find out how well they have co-evolved with us, right? Lice, bed bugs, those things absolutely love us. They think we're fantastic. They can't get enough of us, right? And there are certain species of lice and bed bugs that we can't find anywhere else. We literally don't find them anywhere else. They are only found in urban environments.
Professor, see, I was actually I was reading a paper a few weeks ago about evolutionary responses and how we technically shouldn't be scared of bugs and whatnot, mice, and so we are throughout history we've been scared of sharp teeth, claws, growling, deep sounds, but evolutionarily speaking, we shouldn't be afraid of bugs and stuff like that. So the main reason why people think they're dirty and gross is because of where they hang out. So like cockroaches are found near trash cans and mice are found in dusty walls and whatnot. So that's just become it's a social fear and a cultural fear more than it is a evolutionary and biological fear.
Right,
So
absolutely. And I'm sure you guys have seen the videos of like, maybe some of the bigger, not insects, but bigger animals like our snakes and our spiders. That still is very much the response. evolutionarily that was embedded in us. You can do, I'm sure you guys have seen those really funny videos about cats and cucumbers, right? It looks like a snake. It looks like something that shouldn't be in its space or in its environment.
Exactly.
But with regard to what Riz is saying, absolutely, by default, lots of things eat bugs and insects. And way back when in the tree branching, our ancient ancestors, they had to look for things like protein. They didn't have McDonald's and pre-cooked meals, right? So bugs back in the day were a nutrition source. Obviously, you had to kind of whittle out what was poisonous or unsafe, but 100% correct to what Riz is saying. Theoretically, we shouldn't be afraid of these things. We've now deeply associated them with, again, this social standing of they're dirty. But also there is, I would argue, a fundamental evolutionary aspect to that, in the fact that maybe we aren't responding to teeth and fangs and claws. We are knowing that they do serve as vectors for nasty diseases, things that we don't want to get sick with. So I'd be curious, Riz, send me that paper. I'm kind of curious to read what they talk about with
Yeah,
that.
I'm looking for it right now, trying to.
Yeah, that's a great
I'm gonna
point.
put it on the interesting things to talk about. But
Thank
yeah,
you.
it was actually very fascinating how we used to eat these things, and like all over Southeast Asia, they eat bugs and cockroaches and stuff like that all the time, and they're not afraid of it. They're just it's socially it's acceptable over there. So
Yeah,
socially it's
absolutely.
not accepted here. So that's about it.
It makes 100% sense,
Yeah.
truly, when you think about that. So great point. Thank you for sharing it with us. And yeah, absolutely throw it in the cool things. You guys should check it out. So again, ways in which cities affect wildlife when we think about it. More predation, but less chance of being eaten. Well, it's this predation paradox that we call it. We have more predation because we have pesticides and we have things like giant shoes and pest control. We have literally people whose entire job it is to make sure that pests aren't going crazy. But they're not necessarily being eaten, right? So if I was a pest, if I was a bug, small, inconspicuous, my biggest fear, my only worry was, is something eating me, right? That's always the case, which is super bizarre to think about. Could you imagine walking around in this world and worried about something eating you? That's really bizarre when you think about it, right? Like it's just crazy. Think good, bad, or ugly. I guess thank goodness for the old, meteor that hit the earth, because I don't think we would have outcompeted the dinosaurs eating us if we would have evolved alongside of them. But interesting, we call this the predation paradox, because again, we're wiping out pests, but not through the traditional format of what they're used to. Additionally, there's potentially a higher aspect of biodiversity in towns compared to the forest. Sometimes this isn't always the case, but again, food, resources, water, energy, minerals, shelter, all of those things could potentially lead to a higher biodiversity in a city than the surrounding countryside, because so much food is here. We are like little breeding grounds for a lot of things that are out in nature. And larger population. As you can imagine, right, the three previous ones kind of help us to determine the fourth. So domestic and foreign pests. I'm sure most of you have probably encountered a wild dog or a stray dog, not a wild dog, but a stray dog, a feral dog running around, in Southern Dallas. I see them, I used to see them all the time on Camp Wisdom Road as I was going back to 45. So again, this is, if no one's keeping tabs on them and they're breeding, we're creating packs of wild dogs, right? Feral cats, they can breed extremely rapidly and they can decimate bird populations, reptiles, mammals, right? They hunt very differently than dogs. Dogs are just sort of pretty straightforward with what they're gonna eat and kill. Birds are predators of a different, unique sort, right? They hunt and sometimes they actually just kill just to kill. Goldfish, while there is no natural predator in the United States, they actually are really nasty at spreading viruses, and they can outcompete native fish if we flush them down the toilet or if we throw them into a pond or a river or something, because oh, Bobby doesn't want to take care of his goldfish anymore. I got to get rid of it. I don't want to kill it. So I'm going to go release it to the local pond. That actually can be a really big problem. What are some other things that we can think of that humans naturally release into the wild, thinking it's, oh, that'll be fine. I'm actually letting it have a better life.
I know snakes are usually a big problem, pet snakes.
Pet snakes are a real nasty one for sure. What else? Yeah, good old birdies. Come over to White Rock Lake. There is a whole colony of parakeets, of these parrots that shouldn't be here at all. And they're even in Illinois. There's parakeets that now have survived and thrived for so long through so many generations in and around my undergrad institute. There's a professor doing research on them. They can survive winters now. They know how to, a little bird that came from, you know, basically enough people letting them go from their door from buying them from PetSmart. These things have evolved through many generations and now we're able to actually survive winters in Chicago. Very bizarre. The starling, this is a great example. 1890 was brought to the US by a fan of Shakespeare. Loved Shakespeare. Shakespeare talked about the starling all the time. Thought, I'm going to bring the starling to the United States. Brought it to New York, released 100 into Central Park, thinking, oh, I'll bring starlings here. It'll be lovely to see them. By 1928, they became large enough in population size to reach the Mississippi River, meaning they had enough that they could actually continuously move and relocate. In 1942, flocks of up to 1 million are out starving bluebirds, meaning they're out competing bluebirds and starving out bluebirds and woodpeckers. And right now, today, from 1890 to today, there's a rough count of about 200 million of these starlings because there weren't anything, there's nothing to outcompete them. They're not native to here, but there's enough overlap in temperature and climate and food that I can actually survive pretty darn well without anything needing to compete against me. Okay, guys, I am going to stop there. I will finish 10 and I will complete 11 for you in probably 20-minute chunks. I won't talk for a straight hour and a half. I'll drive myself nuts, but look for that to be posted. So again, no class virtually, but I will be posting the remainder of chapter 10 and chapter 11. I'll get up for you by Wednesday. Probably be done over the next 2 to 3 days. So just keep an eye out for that. Any other questions that I can answer for you guys at this point?
Real quick, so the test, we're taking it by ourselves, correct? At home here?
No tests for this course whatsoever.
Oh, right. I'm so sorry. I thought this was cell biology. My bad.
That's okay. You're in cell. That's okay. But yes, no tests for this. All you're doing are major projects. So again, I will start giving feedback on your project proposals soon enough. And then again, go back please to that video that I posted under the Panopto recordings for walkthrough of the project proposal. It pretty much touches on everything you guys are going to need to know about how to appropriately navigate that, including how to find resources, where to find resources for primary and secondary, and so on and so forth. So if there's no other, oh, go ahead.
I have a question regarding the annotated bibliography part that we have to submit on October, I think. We have to just put it in, can we put it like in number forms, like number 1, number 2, number 3, number 4, and 5?
Yes.
Will that be allowed?
Yes, absolutely. Just know that when you are going to put together your annotated bib for the final project proposal, 2 things. The first and foremost, you're going to, in this annotated bibliography, the submission you're giving to me on the 10th of this month or next month, you're going to tell me the paper in full APA citation format, and then you're going to give me a little blurb as to why this paper is going to help you write the paper. Use that to your advantage. If you're starting to write sentences about why that animal is important, you can basically go back and pull that and put it into your paper. The thing I'm not wanting you to do not copy and paste the introduction or the abstract from that paper and give it to me. That's not the goal of this. The goal is to get you to walk through, why is this paper going to help me in terms of making my project proposal? Why is this paper going to help me to understand that this native species of plant or animal is important? The second thing is maybe helpful just to kind of get it in the format now. When you give them to me, you can give them to me in two ways. The first is you can give them numbered based on the number that's tied to the way you put that citation in. But if you give me no numbers and you give me the last name of the author et al. And the number inside of the citation work of your paper, then you have to put them in alphabetical order when you create your annotated bibliography. And so again, I talk a little bit about that in the project proposal. So it depends on which way you're going to do it. If you're going to number them, right, then the number should be associated to the citation that you're pulling from in the paper itself. Don't do both. You shouldn't be doing number one with the last name and et al. It doesn't make sense. It wouldn't make sense in the citation. But if you just want to use the last name of the author and the year that they produced this, totally fine. Then your annotated bib should be in alphabetical order. So depending on how you want to do it, that's up to you. That's your discretion. But you're picking only one or the other.
Okay. Thank you. Also, we have to have a title page specifically, right?
The title page is just good practice. I would say get in the habit of it so that when you're submitting it, think of all of these things as just, you're sort of doing the prep work for when you put together the final paper. That's really all you're doing.
And the annotated bibliography shouldn't be more than a paragraph of explanation of
Not absolutely, just a couple sentences why you think it's going to be helpful so that, again, you can go back, take that paragraph or that little bit of information and put it into your paper. Now, when you give me your final paper, do not give me the annotated bib with your definitions and explanations. You just want to complete, like a peer review, you're just giving me the citations, right?
Okay, thank you very much.
You're welcome. If there are no other questions, I'll hang out for another minute, but if not, you're free to go. Have a great day, guys. I'll see you next week. Emily, did you have any questions?